I hope they are staying safe at home. Coronavirus is real, but we will pull through. Today, we want to talk about media. Remember that before we went on the lockdown occasioned by COVID-19, we have treated mean and the mean, both the mean of ungrouped data and the mean of grouped data. So now we are going to look at median. Now, median is a point that divides the data into two equal parts. Let me take it again. Median is a point that divides the data into two equal parts. It can also be defined as a score in which above 50 lies half of the data and below lies half of the data. Okay? The class or the score at which 50% of it lie above the data and 50% of it lie above the data. What I would say in essence, that median is a point that divides the data into two equal parts. And this afternoon we're going to look at both the median of an ungrouped data and median of a grouped data. Now, a data is ungrouped if the range or inclusive range is less than 15. And secondly, if there are no many scores in that data, you can say that that data is ungrouped. There are two conditions. Number one, there are no many scores in that data. And then number two, the range or inclusive range is less than 15. We'll talk about this in class, but for emphasis, a data is ungrouped if the range or inclusive range is less than 15. Range is defined as the highest score minus the lowest score, while inclusive range is defined as the highest score minus the lowest score plus 1. That plus 1 is a constant that makes it inclusive range. We're going to look at median of an ungrouped data. Now, in calculating median of an ungrouped data, there are two things that you must consider: whether the data is odd numbered or whether the data is even numbered. The data is odd numbered if it has number of scores that fall on an odd number. For instance, if it is 3, 5, 7, 9, 11, 13, 15, 17, 19, and so forth scores, it is odd. Now, if you fall on a score that can be divided by 2 without any remainder, it is said to be even. For instance, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so forth and so on. Don't forget about it. Now, I remember that these two conditions must be taken into consideration when you are calculating median of an ungrouped data. Now, the formula for calculating median of an ungrouped data differs based on those two conditions. If you are using an odd number data, the calculation of median will change. If you are using an even number data, the median will also differ. Now, let's consider the median of an odd numbered data. Let's consider this course: 9, 6, 5, 4, 12, 3, and 14. Now look at the scores. 1, 2, 3, 4, 5, 6, 7. Here there are 7 scores. 7 is an odd number. So the first thing you need to do when you have a data like this, a set of distribution, is to renumber it. For instance, starts with the lowest score, 3, you have 4, 5, 6, 9, 12, and 14. Now, the formula to calculate the median of this type of data is given as MDN. MDN stands for median, equal to N plus 1 all over 2 position. Now, for us to calculate this median, remember the number of scores here is 7. So median is equal to 7 plus 1 over 2 position. In that case, we have 8. 7 plus 1 is 8 over 2. Still talking about position. Remember, when you are calculating median, always talk about position. Median is about position that divides the data, or point that divides the data into 2 equal parts. And so 8 divided by 2 is 4th position. And what you need to do now is to bring down the scores again. You have 3, 4, 5, 6, 9, 12, and 14. Now, what this is saying is that the median of this data is on the 4th position. And then you begin to mark out, this is 1, 2, 3, 4. 6 is occupying that 4th position. Therefore, median of this data is equal to 6, because 6 is the point or position. 6 is the 4th position, and so the median is equal to 6. So for this data, the median is 6. The score occupying the middle position, or occupying the position or point that divides this data into 2, is 6. Remember here, we talk about the position, 4th position, and then you bring down the data again, count off to identify the score occupying that 4th position. 1, 2, 3, 4. And so 6 is occupying that 4th position, therefore the median is 6. Now we are going to consider the median of a data that has odd number. We are going to consider the median of a data that has even number. This is median of a data that has odd number. We are going to look at the median of a data that has even number. How to calculate it? Remember, I've said that the formula changes. Now for a data that is even number, the median, the formula for median, MDN, this is the short form of it, is given as half into n over 2 plus n over 2 plus 1 position. Plus 1 position. And then let's give an example for it. Supposing you have a set of scores. Example, calculate the median of these scores. Of this scores. Now you have 10, and then 7, 12, 9, 4, 13, 8, 6, 2, and 1. Now, why is it data called even number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. We have 10 set of scores, and 10 is an even number. So that is why this is an even numbered data. Let me write it, even numbered data. The other one had 7 scores. We say it is odd numbered data, but this one has 10. And 10 is an even number. It can be divided by 2 without any remainder. Now, in calculating the median of an even numbered data, such as this one, this formula is what is used. MDN, which is median, is equal to 1 over 2 into n over 2 plus n over 2 plus 1 position. I must emphasize the median talk about position or point. And then, if you want to calculate this median, the median of this data, first, you are going to rearrange these scores in either ascending or descending order of magnitude. Now, in ascending order, you have 4 is there. No, you start with 2. 2 is the lowest, but I can see 2 there. Then you have 4. After 4, what is the next score? You have 6 is there. After 6, you have 7. And then you have 8. And then 9. I can see 10. And then 11. 12. And 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Meaning that you have finished rearranging the scores. And what do you do again? You bring down this formula. And remember that we have 10 scores here. MDN is equal to 1 over 2. Look at the formula. Anywhere you see n, remember number of scores is 10. So anywhere you see n, write 10. So here you have 10 over 2 plus these figures are already in the formula. 10 over 2 again plus 1 position. Now, what you have now is half into 5, 10 divided by 2 is 5. 10 divided by 2 is 5 again, plus 1 position. And then you have 1 over 2 into 11th position. And that will give you 11 over 2. And that will be 5.5. And so this 5.5 position, you now bring down the scores again. 2, 4, 6, 7, 8, 9, 10, 11, 12, 13. Now, to identify the score occupying that position. Now, this is 1, 2, 3, 4, 5, 6. Now, remember, this is the point. This is the median, but there is no score there. This is the point. This is the point that divides the letter into 2 equal parts, but there is no score there. And then we are assuming that the median must be between these two scores, 8 and 9. So it's 8 plus 9, because there are 2 scores now, you divide by 2 again, and that will give you 8.5. And so median of this data is equal to 8.5. Now, if you want to calculate the median of a group data, remember these ones we have done is just median of an ungrouped data. If you want to calculate median of a group data, you now have to follow a different step. First, you determine the range or inclusive range of that data. Then secondly, you decide the class size to use informing class interval. Determine the class size that you want to use to form the class interval. Then form 3 columns. In column 1, indicate the class interval. In column 2, indicate the frequency and sum. Already you notice that in the frequency column, once you put cross in the frequency column, it must be added together. Then in column 3, indicate cumulative frequency. And then step 6, apply the formula. Median is equal to lower is equal to L plus N over 2 minus NB times W all over FW. Now, what does this formula stand for? L stands for lower real limit. L stands for lower real limit of the median class. Let me say it again. Please take note of this formula and the explanation of the figures there. L stands for lower real limit of the median class. N stands for number of scores in the distribution. 2 is already there. Then NB stands for the cumulative frequency directly below the median class. Cumulative frequency directly below the median class. That's NB. Cumulative frequency directly below the median class. That's NB. W stands for class size or class width. And then FW stands for frequency of the median class. Now, we are going to explain how to calculate it. This is an example. Calculate the median of the following scores. You can see the scores here. Look at the scores, they are all here. And then, what is done first is to determine the inclusive range. Remember that the highest score here is 20, while the lowest score here is 0. The highest score here is 20. The lowest score is 0. 0 is a score. Don't just laugh. 0 is a score. And so 20 minus 0 is equal to 20. And so the range is 20. Now, the inclusive range, if you want to determine it, is 20 minus 0 plus 1. 20 minus 0 is 20 plus 1 will give you 21. So the range is 20, while the inclusive range of this data is 21. And since the range and the inclusive range is 20 and 21 respectively, both of them are greater. Each of them, whether 20 or 21, is greater than 15. And if the range or the inclusive range of the data is up to 15 and above, it shows that that data should be grouped. So this is the group data. That first step here to determine the range or inclusive range is just to determine whether data is to be grouped or ungrouped. And once that is determined, you go forth to form 3 columns. Now, in the first column, indicate your class interval. The class intervals are indicated here. This class interval have a class size or class width of 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Meaning that each class interval consists of 3 scores. Now this is the frequency of each of them. 0 to 2 appear 4 times, 3 to 5 appear 7 times, 6 to 8 appear 16 times, 9 to 11 appear 13 times, 12 to 14 appear 9 times, 15 to 17 appear 6 times, 18 to 20 appear 3 times. And if you add them together, it will give you 58. Now, the next column is the cumulative frequency column. How is it done? You bring this 4 here. 4 plus 7 will give you 11. 11 plus 16 will give 27. 27 plus 13 will give 40. 40 plus 9, 49. 49 plus 6 will give 55. And 55 plus 3 will give 58. The highest score in the cumulative frequency column must equal the total frequency. Otherwise, you know that something is wrong. Now, when you have done this, the first thing you do is to determine the median class. Remember that the total score is 58. 58 divided by 2 will give you 29. Please don't forget this. The total score is 58. And 58 divided by 2, we want to look at the midpoint, is 29. You now begin to look at this cumulative frequency column where 29 is. 29 is greater than 4, is also greater than 11, and is greater than 27. Remember, we are looking for 29 on the cumulative frequency column. It's greater than 27. And then we assume that this 29 we are looking for is inside this 50, inside this 40. This 29 we are looking for is inside this 40. And so the class interval that has that cumulative frequency is the median class. That's why we have written it here, median class, for you to know that our median we are looking for, the median of this data is inside this 40. And then the class interval directly below it, which is the MB, is 27. We have just determined it for emphasis. Now, the median here, look at the formula again. Median is equal to L plus N over 2 minus NB times W all over F W. Now this is median. This MDN stands for median. Now this L stands for lowering limit of the median class. Look at the median class here. This is the median class. 9 to 11 is the median class. 9 to 11 is the median class. So this class interval is our median class. Now the lower limit, it has two set of scores. The one on the left is lower limit. The one on the right hand is the upper limit. Now the lower limit is 8.5. Remember, you subtract 0.5 from the lower class boundary. This lower class boundary, this upper class boundary. The lower limit is obtained by subtracting 0.5 from 9. And what we have is 8.5. And then this N stands for number of scores, which is 58 over 2. And then M stands for the cumulative frequency directly below the cumulative frequency of the median class. And what we have there is 27. This directly, 6 to 8 is directly below 9 to 11. And so the 27 there is the NB. Our class width or class size is 3. That's this 3. All over FW. FW stands for frequency of the median class. Look at our FW here. 13 is FW. And then once you have made those observations, you can go ahead and determine the median. 8.5 plus 58 divided by 2 will give you 29 minus 27 times 3 all over 13. And then we have 8.5 plus 29 minus 27 will give you 2 times 3 all over 13. And then 8.5 plus 6 over 13. 8.5 plus 6 divided by 13 will give you 0.46. And if you add 8.5 plus 0.46, it will give you 8.96. And that proves 9. So the median here, the median is equal to 9. And of course, if you go back to that class interval, you see that there is 9 there. And confirming that, that the median for within this class interval. Now, median has certain characteristics. One of the characteristics of median is that it requires that scores be arranged based on their magnitude, and this can sometimes be tedious. And then again, the median cannot be used for further calculation. Thank you. Remain safe. Listen to health practitioners' advice, and then observe hygiene practices in your house. Thank you. When next we meet, we're going to talk about mood and its characteristics. Remain safe, and God bless you.